In this video, we will discuss the common errors and pitfalls in elementary programming. When first learning to program, some common programming errors often include undeclared variables, uninitialized variables, integer overflow, unintended integer division, and round-off errors. Before we use a variable, that variable must be declared with a data type to allocate space in memory and assigned a value. This requires the assignment operator, the equal sign. It is common in elementary programming to attempt to use a variable before it is declared or initialized. Consider the code on this slide. While you may glance at it and think that the variable interest rate is declared and initialized in the first line, careful observation will reveal that this is not the case and also reveal another common mistake, spelling errors, especially due to case. Because Java is case sensitive, just like passwords, interest rate with an uppercase R is not the same as interest rate with a lowercase r. Therefore, it considers them as two completely different variables. Also, remember that we use camel case in Java, so the accepted name for the variable is interest rate with an uppercase R. Furthermore, interest rate with an uppercase R is never used. We never want unused variables to appear in our programs. In most cases, this signifies an error somewhere in the code. All unused variables should be removed from our program. IDEs such as Eclipse will give a warning on unused variables. When we declare a variable to be of a numeric type, in this case integer, the computer allocates a specific finite amount of space. This means that there is only a finite number of digits or a given largest number that can be stored. When we try to assign a value to that variable that is too big or too small, the result is called overflow. Java will not report overflow errors, so we must use extreme caution to avoid a logical error. A round-off or rounding error results as the difference between the calculated approximation of a number and its exact value. Round-off errors are inevitable because we can only store a limited number of digits in a floating point number. We must always be mindful that all calculations involving floating point numbers are approximated. You may be surprised to learn that when we run the code on this slide, the values that are displayed on the console are not 0.5 and 0.1. Take some time to code these statements and discover what is actually displayed. Later, we will see some direct implications of this fact when we start coding constructs such as conditional statements and loops. In Java, we use the / as the division operator for both integer and floating point numbers. When both operands are integers, the result is an integer value that is achieved by truncating the fractional part. This often results in a logical error. When we want to ensure that the result will retain the fractional part, we must be certain that at least one of the operands is a floating point number. In this code on the slide, we notice that in example A, the result is an integer value. However, in example B, we were able to retain the fractional portion by simply dividing the floating point number 2.0 instead of the integer 2. One common pitfall is that of coding redundant input objects, or scanner objects. This will not result in an error, but is poor coding, as it is unnecessarily creating two input objects, which may lead to subtle errors later in our program. It is not necessary to create a new scanner every time we need to input something from the user. A single scanner will suffice.